Hello, everybody. We're going to move from blood type to genes that are carried on the sex chromosome. So in this next little section, actually these next couple of videos, we're going to talk about that. So in 3.46, it says we're going to start off by just reminding ourselves, like, how is gender determined? So explain how sex chromosomes control gender. You can do this in a Punnett square, right? So the mom can have eggs that can either contain an X or the other X, right? Because females are XX. So the X could end up in that egg, or the other X could end up in that egg. And the dad, he could donate an X, or the other form is the Y. So either one of those two. And then when you cross, like if this egg happened to meet that sperm, you would have a daughter. If that X happened to meet this sperm, you would have a son, right? This is, sometimes they put these Punnett squares like on an angle. I don't really like it this way. But anyway, so that's how X and Y control gender. And you can represent that in a Punnett square if you'd like. The next slide doesn't want to advance. There we go. So the next slide says state that there are some genes that are on the X chromosome that are absent from the Y. And to demonstrate that, I'm going to go quickly to the next slide to show you how that can be. And it basically just comes down to length because of the X chromosome being longer. So if we look at these chromosomes, right, the longer one is the X, the smaller one is the Y. There's this whole region up here called the non-homologous region. My pen just froze. Sorry. So there's non-homologous region up here, and there's also a non-homologous region down here too, right? Where there are genes on the X in a space where there's no DNA, there's no chromosome there, so it's impossible to have a form of that gene on the Y. And this has some implications when we talk about the inheritance of diseases, which we'll talk about in the next video. So let me show you an example of that on the next slide. It has a little bit of a better diagram. So it actually has some of the genes identified. So you can see up here, the X chromosome is on the right-hand side. My pen gonna work? So sad. It has some Duchenne muscular dystrophy, some sort of retinitis pigmentosa. Down here, there's more diseases. The ones that we're going to look at in an IB wants you to know is hemophilia and color blindness. So those two are linked. They are linked to the sex chromosome X, and that's what sex linkage is. It's genes that are linked to the X chromosome, and we're going to talk about the special way we note that as well. Before we move on, there's actually a gene on the Y that is not on the X, and that's good because then there would be, well, maybe it's not good. There'd be no males, right? So there's something called the sex determining region. I don't know why I'm writing this in a weird order. So the SRY gene stands for sex determining, the R stands for region, and the Y stands for the Y chromosome. So there's an area, I'm not sure exactly where it is, but there's an area on this Y chromosome that makes a protein, right? Gene to protein. It makes a protein that is responsible for the primary sex characteristics in males. So basically like all the boy parts. Okay, so to review, gender is controlled by X and Y, right? There are areas on the Y chromosome where there's not genes, and the X chromosome has them. And the definition of sex linkage is basically genes that are linked to the X chromosome and not the Y. Poor Y chromosome is missing out on all the fun.